So hello everyone. Recently I have started this channel. In this channel I will teach you the CSR UGC Net Chemical Sciences. So please subscribe this channel for regular updates. So today what I will discuss. First I will discuss the dehydrohalogenation. The second I will discuss the use selectivity, Zaitsev rule, or you can say Saytzev rule also. And finally I will discuss anti-Zaitsev rule of Hoffman and product. So after discussing these three topics, I will solve some questions in the next video related to these topics. So in the dehydrohalogenation, what happened when you will take this compound, then there is two hydrogen, this alpha hydrogen, then there is this beta hydrogen. When this will react in the presence of base, this alkene will form. So E2 elimination is usually undergo uh, for this type of compounds. So when you will talk about this tertiary halide, this this is the allylic halide and this is the benzylic halide, then there is a possibility of elimination by the E1 mechanism. So in the separate my lecture, I will discuss about this E1 and E2 mechanism. Then there I will clarify you about what is the E1 and what is the E2 mechanism. So here you can simply understand this type of reaction will go by the E2 elimination, and when then this and this allylic and this benzylic halide, the reaction will go by the E1 elimination. Why? Because in the E1 elimination, what happened first, the generation of the carbocation and then formation of the alkene happens. So once in this tertiary alkyl halide, this chlorine will leave as Cl negative, plus charge will be here, and this will be the tertiary carbocation. You know, tertiary carbocation is the more stable, so there is the possibility of the E1 mechanism. Why E2 cannot happen? E2 is a mechanism E2 elimination happens simultaneously, like this removal of this beta hydrogen and simultaneously removal of this the leaving group. Okay, but here in you can see the nucleophile this type of mechanism is not possible because in the E1 passes the generation of carbocation, due to the stability of this carbocation is more, so this will probably go with this E1 mechanism. So okay, so here what is the rate determining step for this? The E1 E2 mechanism. E2 mechanism is the second, follows the second order kinetics. Okay, for the first order respect to the base and the with respect to the alkyl halide. Okay, so in detail we will discuss in the next slide. You can see this is the six-membered. This is the six-membered haloalkane when we react with the base KOH and in the solvent ethanol, what we will remove, HBr will remove, and this alkene will formed. So how this mechanism will happen? We will draw the six chair form of this compound. When the chair form of, we will draw this chair form. In this chair form, this hydrogen and this bromo are in the equatorial position. Both are equatorial positions. This is the axial position, this is the equatorial position. This hydrogen and this hydrogen, one is axial, one is the equatorial, so they are the cis, they are in the cis form. So there is the uh, no possibility. So when this type of structure will exist, so E2 mechanism will not happen. So E2 mechanism will happen generally when they are both are in the opposite directions, anti to each other. This bromo is axial, this hydrogen is also axial. These two are anti to each other. So when this structure will exist, the E2 elimination will happen. So here this base will abstract this hydrogen and Br negative will remove here. So this in this way this alkene will form by the E2 mechanism, E2 elimination mechanism. So in the more example you can see you can see this in this structure. When this is not cyclic, you can draw this type of conformation. In this conformation, base will abstract this hydrogen and this halogen will remove, but these are at the syn elimination. This syn elimination usually does not happen. Now if this is the conformation, then both are the anti to each other and E2 elimination will happen. What is the reason the E2 elimination usually happen by the anti-elimination mechanism? Because we can see the best overlap of the orbitals is possible, and both are the opposite orbitals overlap is best, and the repulsion between the electron rich base and the departing electron rich halide can be avoided. Okay, the interaction between this base electron rich base and this leaving group electron rich, there is a possibility of electron interaction, and this can be avoided by this anti-elimination mechanism. So this E2 mechanism usually happen by the anti-elimination mechanism. So in the further study, you can see when this is a straight chain halogen, this is a straight chain halogen will react with the potassium tertiary butoxide in the immersed solvent. There is the formation of the alkene. So now this is an not sterically hindered. If we will use not sterically hindered this base, then there is also possibility of the isotope mechanism. But here we are using sterically hindered base, so elimination will be elimination product will be formed as a major product. So what is the order of activity of the leaving group? So it is a alkyl fluoride, hello alkyl chloride, alkyl bromide, and alkyl iodide. Here, when this is the alkyl iodide, the rate of reaction is the largest because iodide is a very good leaving group. And when we will move down the periodic table, the size of the halogen increases. So this is the weakest bond, and this is the best leaving group during the dehydrohalogenation reaction by the E2 mechanism. So this is the we have learned about the E2 mechanism, E2 elimination mechanism. Now when this type of alkene, there is a possibility of the formation of two type of products, this one and this one. So at that time we have to see about the reduced selectivity Zaitsev rule, or you can say Saytzev rule. So when we will use this alkyl halide and react in the presence of a base and solvent, there is a possibility of formation these two products. But according to Zaitsev rule, more substituted alkene will be formed. This is the more substituted alkene. You can see this double bond. There is 2-methyl. There is 1-methyl. Here is this double bond. There is no methyl here. So this is a more substituted alkene is formed. This will be the major product. How it is formed? So there is a hydrogen. One hydrogen is here. Here hydrogen are there. 3 hydrogen are there. Here is also hydrogen. So either this hydrogen will be abstracted or this hydrogen. So if this hydrogen will be abstracted, this will be the product, and if this hydrogen, this anyone will abstracted, this will be the product. So what the Jackson rule says, the E2 elimination happen, the major product will be more substitute alkene. Why the more substitute alkene? This more substitute alkene is stabilized by the alkyl by using the plus I effect. So in the next slides, we will discuss about what is the region of the major product formation using the this Zaitsev rule. So we have drawn here we have taken this compound. This is the energy. So you can see there there is a lower energy required for when this proton is abstracted from here, related to more energy required to abstract this proton. So this product is kinetically favored. When once the product is will form by using this mechanism, and this product will form, and by when this proton will be abstracted, this one, the product will be formed this. So you can see this is the more stable product by the plus I factor of this methyl, and this is the less stable product. So this is the more stable thermodynamically and kinetically favored product. So Zaitsev rule, using the rule follow the E2A, while the reaction happening by the E2 elimination, major product will be the more substituted alkene. There are exceptional cases when this rule does not follow, when the leaving group is this fluorine. So instead of bromo, if there is fluorine leaving group, then this rule does not follow. When the leaving group is chlorobromide, and this rule will be followed. Now we will see the case of when this rule will not follow. So in such a condition, in such situation, what will be the product? So in this we will say the product will be the follow the anti-Zaitsev rule or Hofmann product. So we have taken now fluorine here instead of bromine. We reacted in the presence of base or in solvent. The major product will be the less substituted alkene, and minor product will be the more substituted alkene. Why this is happening? This we can see by the mechanism. We have taken this haloalkane. Base will abstract this proton. When this base will abstract this proton, this product will be formed. When base will abstract this alpha hydrogen, so product will be formed this one. So what is the reason of formation of the this major product in the fluorine? Because there is a one major reason is fluorine is less reactive toward the as a leaving group. So in that case, what happen? This proton is abstracted, and this proton will abstracted, and this proton, when the proton will be extra negative charge will come here, this will form as a carbanion. As we know, primary carbanion is more stable than the secondary or tertiary. Here is the formation of the primary carbanion. So this reaction is going through the primary carbanion. The intermediate formed is the more stable in this reaction mechanism. So product will be the major. This reaction, when this proton will be accepted, you can see this is the carbon formed. This is surrounded by this one carbon, and this one carbon. This carbon anion is secondary carbon anion. This carbon anion is primary carbon anion. So this reaction is going through the secondary carbon anion mechanism, secondary carbon anions, but secondary carbon anion is there is intermediates forming that is less stable due to the presence of this adjacent alkyl. So in that case, minor product will be this due to the unstability of this intermediate. So here E2 elimination happen follow Zaitsev rule when the leaving group is chloro, bromo, iodo, and fluorine left substitute alkene will be formed. So this is due to the poor leaving group nature of the fluoride, and second, partial negative charge developed on the beta carbon, not on halogen. Okay, negative charge developed on beta carbon, not on halogen. And the last one is the reason is stability of the carbon anion formation. So there are another also case, some exceptional cases uh, when the anti-Zaitsev rule followed or open product formed. There are what are the cases when this leaving group is bromo and we are using the hindered base potassium tetrabutanoxide in the presence of solvent. Then there is also product formation of the minor of this more substituted and measure this less substituted. Because the difference is here base is potassium tetrabutanoxide. Sterically hindered base we are using, so it will be difficult to accept this proton for the sterically hindered base to remove this proton. Okay, the second, so when the base is more hindered, the major product will be this less substituted alkene. There another one is exceptional is that when the chloro is there and double bond is there, when the remove this hydrogen, the product will be formed. This will be the product form. There is a true double bond. These two bonds are in conjugation to each other, so this is the more stable. So this will be the major product, and here is the double bond are not in conjugation and less stable, and this will be the minor product. Thank you everyone. Please subscribe for the daily classes, and in the next class I will solve all the questions related to CSI UGC net for the chemical sciences based on these concepts. Thank you.